Cybersecurity analysts must understand how network switching works, but not only how it works, when to apply it to a given situation. Many of the Cybersecurity Analyst Plus exam questions are scenario-based, where you're going to need to know what to configure to improve the security posture of a given scenario, and that might include things like network switches configured in a specific manner. So network switching, a hardware device that has multiple network connection ports. That's a switch. You could have multiple switches linked together, of course, if you have a lot of devices plugged into the network. A network switch has its own memory, its RAM, and it remembers the device MAC address that is plugged into a specific switch port. By doing this, it allows multiple concurrent conversations between devices plugged into the switch, unlike a traditional network hub, which physically looks the same. You've got a bunch of ports, you plug stuff into those ports, but on a hub, only one conversation can take place at a time. There's only one collision domain on a hub. Now, because a network switch is primarily focused on remembering things like MAC addresses, you might recall that a MAC address is the 48-bit hexadecimal address that uniquely identifies a network interface card, and that applies to layer 2 of the OSI model, the data link layer. So therefore, a network switch maps to layer 2 of the OSI model. Now you can also get layer 3 switches, which have routing capabilities in addition to the standard layer 2 functionality of a switch. And the routing is used between VLANs, virtual local area networks. Let's talk about VLANs. This is a very big deal from a network performance and a security perspective. A VLAN, or a virtual local area network, allows you to segment a larger network into smaller ones. Why would you want to do that? Better performance? If you know you have a group of machines, maybe for workstation imaging from an imaging server, that takes a lot of bandwidth. You might want to have that on its own VLAN. But then if you've got sensitive data being handled by certain user stations and certain servers with databases, maybe from a security perspective, that should be isolated on its own VLAN. In our diagram, we've got an Ethernet switch where the first 4 ports are organized into the OS imaging VLAN, and the last 4 ports are organized into the accounting VLAN. Now, certainly a switch can have a lot more than 8 ports, and there are different ways to determine VLAN membership beyond just which port something is physically plugged into, but that's one common way. From an exam perspective, just bear in mind that network segmentation through a VLAN, which is possible on a layer 2 switch, you don't need a layer 3 switch to do this, can go a long way in helping to secure sensitive data being used on a given network. At the network level, we also have to think about Network Access Control, or NAC. This is often referred to as the IEEE 802.1x security standard, which is a capability of specific models of things like network perimeter devices, network switches, wireless routers, VPN appliances, even dial-in modems, which are, believe it or not, still in use in some cases as a last resort mechanism for making a remote connection to a network should everything else fail. Okay, but what is it? What's network access control? Well, first of all, terminology. A supplicant is a device trying to connect to a network, whether it's a smartphone, a laptop, whatever the case is.